let there be no cell. So after closing switch, the capacitor will behave like a source of EMF. Because look at the plate, this is AB. So from here, what is VAB equal to? Q naught by C. From where that Q naught has come? Due to charging of circuit. Or in the first circuit only, I'll throw the switch from 1 to 2. I'll throw the switch from 1 to 2. It is like this. At steady state, I'll move the switch from 1 to 2. Okay, this is about VAB, that one. So initially, the capacitor is having some energy. So from here, what is the conclusion? VA greater than V. The moment you close switch here, the potential of plate A greater than B. So what will happen to charge? Charge will start flowing from high to lower potential, and there's a path. So therefore, the current starts flowing here. So there's a discharging current. And how do it will flow? Like this. So this will be plus minus. Write the loop equation. Minus charge at an instant of time. Let it be Q. This is at t equal to 0. This is at time t. Now write the equation. Q by C plus IR equal to 0. Or this is Q by C equal to I into R. Now look at the charge across capacitor decreases, no? So therefore here I should be minus. This is a convention, please do follow, very important. If charge across capacitor decreases, I equal to minus dq by dt. Charge across capacitor increases, I equal to plus dq by dt. Substituting this will be Q by C minus dq by dt R. See, nowhere we are making any guess. KCL, KVL, and some convention like I equal to plus dq by dt minus dq by dt. That's all over, finish. Whatever the complexity of the problem, just we'll stick on to the basic things. And we'll apply KVL. KVL is the thing which we are widely using here, you can see. So further, this will be dq by q equal to dt by RC. So initial charge in the capacitor, Q naught, charge at any time, let it be Q. So this should become Q is equal to log of minus T by RC, where lambda, again we'll write it as RC. So this will become Q naught So look at the conditions now. Look at the charge, all the quantities, like a charge here. It decreases. So I want current. So I'll differentiate this. If I differentiate this, dq by dt, this should be equal to minus q naught by lambda e to power of minus t lambda. So this should be equal to minus of dq by dt should be I. Lambda is what? RC. Now look at the current through the circuit. It also decreases exponentially. This conclusion is very important. Now, when you switch on TV, so what do you expect the television? How we should switch on, switch off? Immediately, no? Or you switch off that power off gradually. What happens? The brightness of the screen gradually decreases. Then the volume decreases gradually. How you feel? So what type of response you want now? Immediately, no? If I switch off if I power off immediately, when the screen, what happens? The brightness should become 0. And if I decrease volume of screen, the volume will gradually decrease. No, if you decrease volume, volume should decrease here. If you switch off the tube light, the bulb, then what happens? The brightness of bulb gradually decreases. No, nothing like that. We want all the actions immediate, no, or in a less time. So what do we expect this response here? No. So the response I plot it. This will be the response. So what is this? I naught, I'll call this the initial current. I naught lambda. So this is what? That I naught. And this is time. So what do you want? How the curve exponentially decreasing? No doubt it's exponentially decreasing. But what we want the response should be what? Immediate, no? So tell me what I should do in the circuit here now. What changes we have to make it? Value of R and C. Shall I make it R large? If I make it R large, no, it will take more time for the circuit to power off for the television or mobile anything. So again the lambda should be as least as possible. So for electrical equipments, time constant of circuit should be very large or should be very small. Very dangerous question for you in exam. Huh? It's no way discussion is made in the book. But the overall why we are discussing this for that application only. I'm making things clear, especially for mains. No, advanced is you may ask in passage, but in mains definitely will trouble you with questions of these higher applications like. Why this discussion is, you look at the insight, he has introduced word transient word, he has brought it. So definitely open, he can ask you anything here. No? So what should be the basic requirement for electronic equipment in terms of time constant? Should be as least as possible. That's all. If it's a large value, then to power off, even you switch off television, it will take 5 minutes to switch off completely, means it's of no use. No bulb, okay, switch off. Then gradual after 5 minutes, what happen? The light emitted by bulb will become zero. Fan, though you switch off, slowly what happen? The angle will be decreasing and comes to rest. After 5 minutes, it will come to rest. I think so. This is the unwanted thing. No? So even this response also should be it should decrease exponentially in a very less time. Means the current I should become zero in less time. So practically what happens? 5 lambda again. Again, what I should do with the lambda? As small as possible.